In this video, what I'd like to do is obtain the model for current I1 given this circuit. And this circuit has two voltage sources, V1 and V2. It also has three different elements in it. It has this inductor right here, it has a resistor, and it has a capacitor. So before I go through and analyze this circuit, I just want to take a quick minute to go over these different elements and what the voltages over them will look like. So first I'm going to start with my voltage source. So if I have a voltage source and when I'm tracing my path, I go from the negative to the positive, so I'm going this way, I'm going to want to add in that voltage source. If I go from the positive to the negative, I'm going to subtract that voltage source. The way I think of it is whatever I see last. So if I'm coming out of the plus side, I'm adding it. If I'm coming out of the minus side, I'm subtracting it. Okay, now with the resistor. Well, the resistor, if we have a resistance R and we have some current going through, my voltage over this resistor is going to be the current times the resistance. If I look at my capacitor, and again, I have some current going through, and here's a capacitor. The voltage over the capacitor, I'm going to say is 1 over C times the integral of I dt. And finally, I have this inductor. And if I have an inductor with some inductance, and I again have a current, the voltage over this inductor is going to be L times di dt. And finally, we need to know if we're going to add or subtract these. Well, if we're going with the current, we are going to subtract. So we're going to subtract any of these voltages if we are going in the direction of I. We're going to add if we are going against the current. So now that we know how we're going to deal with these voltage elements, let's start analyzing the circuit. I'm going to call this right here loop 1. I'm going to call this right here loop 2. So for loop 1, I'm going to go this way. I'm going to force whatever my voltage is to be positive in my analysis. So with 1, I start at V1. I'm going through it this way. I'm coming out of the plus side. So I'm going to have V1. Now I'm going in the same direction as current I1, and I'm going over this inductor. So we're going in the same direction, so we're going to subtract it. So I'm going to say minus L d I1 dt. And now we're going this way. So we're going over this resistor, again in the same direction of my current I3. So I'm going to have minus R I3. And then this is going to be equal to 0. Now I'm going to look at loop 2. And in loop 2, I'm going to go this way. Just so I like having my voltage source that I start at be positive. So for loop 2, I'm going to be going this way. So I'm going to be coming out of the plus side. I'm going to have plus V2. I'm going to, right here, I'm going this way, so I'm going against my current. Because I'm going against my current, I'm going to add in the voltage over the capacitor. So I'm going to have plus 1 over C times the integral of I dt. Then I come this way, and I'm going again with I3, so I'm going to subtract minus R I3. And I just need to change this right here. This isn't a capital I. This is actually going to be I2. All right, so now that I've fixed that, this is also equal to 0. We now have three unknowns, right? We have I1, we have I2, and we have I3, but we only have two equations. So we need one more equation. And if we look at this node right here, we see that we have I1 coming this way. We have I2 going this way. And we have I3 going this way. If we sum the currents at this node, what we're going to get is our third equation, and we're going to have I1 is equal to I2 plus I3. Now we have three equations, we have three unknowns, and we can solve for any of these currents. We could solve for I1, we could solve for I2, and we could solve for I3. To spare you 20 minutes of doing algebra, I just have chosen to do I1. So to solve for I1, this is the way I'm going to go about it. I'm going to solve this equation right now for RI3. If I have RI3 is equal to V1 minus L di1 dt, and I solve equation 2 for the same thing, I have RI3 is equal to V2 plus 1 over C times the integral of I2 times dt. I can just equate these two equations together with this RI3. So I'm going to do that. I'm going to say, all right, so this is now equal to V2 plus 1 over C times the integral of I2 dt is equal to V1 minus L di1 dt. Now, I want to get rid of this integral. This is a personal way I like to do this. I like to get rid of those integrals as soon as I can. And to do that, we're going to take the derivative of both sides. So we're going to say dv2 dt plus 1 over c. And when we take the integral of this, it just becomes I2 is going to be equal to v1, we need the integral, the derivative of this. So dv1 dt minus L, well, this is already a derivative, so it becomes a second derivative. So d2 I1 over dt. Okay, so now what do we have? We have I1 over here, but we still have this I2. How can we solve for I2? Well, we can use equation 3. We can say I2 is equal to I1 minus I3. So we can substitute that back into this equation. When we do that, we're going to get dv2 dt plus 1 over c times I1 minus I3 is equal to dv1 over dt minus L d2 I1 over dt. Oops, I forgot that 2 right there. So, okay, now let's just simplify this a little bit, I guess, would be the next thing I would do. So I'm going to have dv2 over dt plus 1 over c times I1. I'm going to do it this way, I1 minus 1 over c times I3 is equal to dv1 over dt minus L d2 I1 over dt squared. So we just need to now figure out what our equation for I3 is equal to. Well, we could go back to this equation right here, and we could solve for I3. Really, this equation, when in this part, we could say I3 is equal to 1 over R times V1 minus L di1 dt. This is also equal to V1 over R minus L over R di1 dt. So I can substitute that now in for I3 right here. So if I do that, dv2 dt plus 1 over c I1 minus 1 over c times V1 over R minus L over R di1 dt is equal to dv1 over dt minus L d2 I1 over dt squared. Okay, so now we're in really good shape because all we have are this variable I1. Now we just need to distribute some terms and bring all of the i's to one side and everything else to the other side. So let's do that. Let's distribute this term right here. So I'll have minus V1 over CR, and I'll have plus L over RC, or keep it the same way, CR, di1 dt. So now let's just bring all of my i's, say, to the left side. So I get this is L d squared I1 over dt squared. So that's this. I'm just going to put a check mark over it. Now we have minus L over RC d I1 dt. So we have this one. And we have this guy right here. So we're going to have plus 1 over C I1. So here's all my i's. And now to the other side of the equation, we're going to put all the voltages. So we're going to have minus dv2 dt. We're going to have plus v1 over RC. And we're going to have what's left plus dv1 over dt. Now the last thing I'm going to do, I just need a little bit of space, is I'm going to just distribute the r's and the c's so I don't have this 1 over anything. So I'm going to multiply every equation by RC. When I do that, this is going to be the final equation. I'm going to have L R C d squared I1 over dt squared minus, well, this is just L di1 over dt. Then this is going to be plus R I1 is equal to RC times minus RC times dv2 over dt. We're going to have this RC is going to cancel, so plus v1, and then plus RC dv1 over dt. And I think that's all on the screen. So this right here becomes your answer. This is the model for our current I1, and given this system that's now cut off. But you can do this. You can solve those equations for I2. You can solve those equations for I3. When I was doing this, I found I3 to be pretty straightforward, but I did work a little while on I2. The equations I needed to solve, it just wasn't what I was expecting. But you can solve any of these equations for I1, I2, and I3. And if you're struggling, I would suggest trying to solve these equations for I2 and I3.